Today's objective is the Pythagorean Theorem. A right triangle has one angle that's 90 degrees, and this cool feature lets us find the side measurements discovered a long time ago using a formula named after its creator, Pythagoras. It's called the Pythagorean Theorem. The legs are the sides that meet at the 90-degree angle. It doesn't matter how it's oriented. If they meet at the 90-degree angle, those two are the legs. The hypotenuse is the longest side, and it is opposite the right angle. The hypotenuse is always opposite the right angle, and opposite means across from in this case. We call the legs A and B. So I could say that this is leg A and this is leg B, or I could do it the other way around. The legs are just both A and B, and the hypotenuse is always C. Okay, so even if it's turned sideways, you still call the angle that's across from, the line that's across from the right angle, that's C. So the totally cool formula tells us if we square leg A and square leg B, the lengths of those legs, and then add those squares together, it will be the same number we get when we square the longest side, the hypotenuse. So this is what I'm saying in a formula. The side A squared plus the side B squared equals the side C squared, okay? But A plus B does not equal C. You have to square the sides. And you can see some really cool videos on YouTube if you look up Pythagorean Theorem. All right, let's do a few problems. So here we have a triangle and here we have a triangle. Notice here we're missing side C. Here we're missing, which is the hypotenuse. Here we're missing one of the legs. I could have called it A, I could have called it B. I just called it A, okay? So these are the steps we do. Write the Pythagorean Theorem every single time. Substitute the two sides you know. Solve appropriately. And remember, shapes don't have negative measurements. So since we're squaring, we could have two answers, but one of them is not going to be appropriate for this case. All right? So here we go. A squared plus B squared equals C squared. And in this case, we know both the legs, so we know A and B. So I substitute in 8 squared plus 6 squared equals C squared. 8 squared is 8 times 8. C squared is 6 times 6. And those still equal C squared. 64 plus 36. Well, 64 plus 6 is 70, and 70 plus 30 is 100. So 100 equals C squared. Now, how do we solve a problem that's squared? What's the inverse operation? Taking the square root. So we would take the square root of both sides, and I'm going to flip it over and write C first. So C could equal plus or minus 10, because when you're doing the square root, you're thinking what times itself is this number, and 10 times 10 is 100. But in this case, we can't say it's negative 10 because there's no negative measurement in geometry. So C equals 10 inches. Okay, your final answer has to have your measurement with it. Let's do this one. This time I'm missing a leg, so I have the hypotenuse and I have the other leg. So I'll write the formula. A squared plus B squared equals C squared. I don't know what A is this time, so I leave the A squared there, plus 12 squared. You know what I did? I messed up my measurements. This should be, hold on one second. This should be, otherwise you'll look at it and go, that doesn't make sense. Let's make this be the 12 cm and this be the A, okay? I'm sorry, it just looks better this way. We'll get the same answer. You'll see what I mean in a minute. All right, A squared plus 12 squared equals 13 squared. A squared plus 144 equals, do you remember what 13 squared is? What's the way I said you could remember it? Count by threes, 3, 6, 9. So 100, oh geez, sorry. Let me just, oh, I'm going to erase her. Oh, I'm going to make a mess. 169. Now notice in this problem, when we had a and b, we could just add the two together to find what c squared is. But in this problem, when we have a little bit of a mess, when we have a and b on this side, in order to isolate a, we have to do the inverse. So we have to subtract the 144. Sometimes the way that I hold the pen makes it thicker or thinner, so that's why it's thicker. So 144 minus 144, that's 0. So a squared equals 9 take away 4 is 6 take away 4 is, so a squared equals 25. Take the square root, take the square root. A could equal positive or negative 5 because it's a perfect square. However, since this is measurement, there's no negative measurement. So a equals 5 centimeters. See why I switched it? Because it wouldn't make sense if the long side was 5 and the short side was 12. I knew what numbers I wanted, I just put them in the wrong place. All right, so we're done with those two. But what if the sides are not whole numbers, or not all whole numbers? And when the sides are all whole numbers, they're called Pythagorean triples, and they're special. So I've given you two. I'm going to tell you one that's used a lot. It's 3, 4, 5, and this are sides A, B, C. The one we did here was 6, 8, 10. Do you see a relationship between the 3, 4, 5 and the 6, 8, 10? The 6, 8, 10 is just the 3, 4, 5 multiplied by 2, isn't it? But here's another one that's used a lot, 5, 12, 13. So in the book, they talk about how to figure out what they are, but I just want you to recognize that those are special Pythagorean triples. All right, so let's do this one. When we get our answer, we're going to leave our answer as a simplified square root. We don't need to use a calculator to be more exact, or we can, if we can estimate the, if we can't simplify it, we could estimate the answer by finding the two perfect squares that it's between. So here we go. A squared plus b squared equals c squared. I always put the smaller number first. 4 squared plus 8 squared equals c squared, because in this case we're finding the hypotenuse. 4 times 4 is, 8 times 8 is, and then we have c squared. So 16 plus 64, 64 plus 6 is 70, plus 10 is 80, so 80 equals c squared. So to solve a square, you do the inverse, you take the square root, take the square root. So we could say c equals the square root of 80. Well, since it ends in a 0, I'm thinking maybe I can divide that. And when I look at it, I think, oh, this is 8, it's 8 times 10, okay, but it's also then 4 times 20. So let's say I said c equals the square root of 4, which is a perfect square, times the square root of 4, which is a perfect square, times the square root of 5. Then I think, oh my gosh, that's really could be the square root of 16 times 5. But it's okay if you do individual perfect squares also. We could say c equals, and this is, plus or minus 80, so plus or minus. But I'm going to leave the minus off now because I know the measurement can only be positive. Okay, but normally if I was solving this problem, if it wasn't measurement, I would say plus or minus the square root of 80. So square root of 4 is 2. The square root of 4 is 2, and the square root of 5 can't be simplified. But now I can multiply 2 times 2 and get finally that it's 4 times the square root of 5, which if I had done the square root of 16, I would have figured out. Hope that wasn't too confusing. All right, let's do one more. A squared plus b squared equals c squared. And here we have 5 squared plus 8 squared equals c squared. 5 times 5. 8 times 8, c squared. Okay, so 25 plus 64. So 64 plus 5 is 69, plus 20 is 89. 89 equals c squared. Square root both sides. C equals the square root of 89, plus or minus. All right, now we know for geometry that it's only going to be plus, so I'm going to say, I can't think of anything that goes into 89 perfect squares, so I'm going to say, well, what are the perfect squares around it? Well, the square root of 89 is close to the square root of 81 and the square root of 100. It's 9 from this, it's 11 from this, so I'm going to say C is approximately 9 meters. A little bit over 9. I could say 9.5, I guess, but that's what we're going to do. We're not using calculators when we're figuring these out. That's it.